Howdy. There has been some interesting news. Let me translate this. With the help of Google. A large disturbance over the Baltic Sea. There is no information about the cause of the disturbance. The airline Finnair has confirmed to STT that the GPS system is currently being disrupted in the southern Baltic Sea and over the southern tip of Sweden and Poland. Signs of massive interference with the satellite positioning network, i.e. GPS system, have been observed in the southern Baltic Sea. You can find out from the GPS Jam website, which collects GPS data from open sources. There is currently no information on the cause of the disturbance, but it extends over a wide area. According to the Polish language media, mysterious and massive GPS signal disturbances extend from southern Sweden across the Baltic Sea to Poland. The airline Finnair has confirmed to STT that the GPS system is currently being disrupted in the southern Baltic Sea and over the southern tip of Sweden and Poland. Yeah, obviously they repeat themselves. According to the company, the phenomena does not affect flight safety or Finnair's flight schedules or routes. Our pilots are also very aware of possible GPS interference in different areas. Finnair's communications are answered by email to STT. So here's a map, which I find very interesting. Probably you too, if you just hold on a second. Here's Denmark, here's Sweden, Norway. And yeah, Finland is not visible anymore. But anyway, here somewhere is the border between Big G Germany and Big P Poland. Yeah. According to the Polish media, the Polish aviation agency warned Polish pilots about this for the first time on December 25th. But since then, GPS interference has only increased. The Polish Agency for Electronic Communications cannot explain the cause of the GPS interference, but its experts suspect that the interference may be caused by the weather. Our experts have found a correlation with media information and the weather situation. Whether this is the real reason for GPS malfunctions will become clear in the coming days. The agency spokesperson Witold Tomaszewski tells the TVN24 news channel. However, John Wiesemann, who runs the GPS Jam website, points out on social media that no similar disturbances have been detected in the area, at least in the almost 2 years that his website has been in operation. Massive new region affected by GPS interference in the past 24 hours, including Poland and the Baltic, compared to the 24 hours before on the right. That's not really visible here where exactly that spot is. But anyway, greetings. And it's even bigger and more intense now. I'm not a space weather expert. That's very cool. He's talking about space weather. But I think it's unlikely to be space weather, which has ever. Alright, this was the tweet. Wiesemann points out that he is not an expert in space weather, But he does not believe that recent solar storms, for example, can explain such widespread interference. He would also exclude Russia from the perturbators. The pattern above Poland suggests that it's not Russia, for once. A NATO exercise, he ponders. Jari Pöntinen, head of Traficom's aviation at the Finnish Transport and Communications Agency, tells STT that Traficom has no information about GPS interference in the area so far. All right. Yeah, so I guess he's working also together with the Finnair, the Finnish airline. And just here before they said there is no danger or whatsoever. No, they are saying that the GPS system is currently being disrupted in the southern Baltic Sea and over the southern tip of Sweden and Poland. So anyway, let me show you something. Yeah, the North German Conductivity Anomaly. Revisited. For those who have been watching my videos for a while, you probably know about the Fennoscandian surface conductivity anomaly. The one in Finland, Sweden, Norway, and it expands to Russia, where you find the Ksk Magnetic Anomaly. And I once found some other maps about similar things, and it seems that the Ksk Magnetic Anomaly is connected all the way down to the Black Sea, where we have the Crimea Island in the Ukraine, and there is a huge water body. Let me just show you quickly, if you never have seen something like this. That's the surface conductivity anomaly, obviously. And to me, it seems to have a sea pinch or a vortex-like structure, maybe it's better said like that. And I'm still not too sure if the red depicts more conductivity and the blue less conductivity, or are these positively and negatively charged areas? If they would be, they would probably exhibit the direction of this magnetic vortex, which would affect the weather. High and low pressure systems. And this is very sketchily made, but it goes down to here. Here it's not visible, but if you're once bored and don't know what to look out or on in the internet, take a look at that area. You will be amazed. But anyway, that's the surface conductivity anomaly I have been talking about very much. It is shown in the papers I made and stuff like that. I think it's very interesting. We could actually just now take a look at that, try to grasp. So there is basically also a little bit a red area, which goes all the way up here. Here is the Ksk Magnetic Anomaly. Here on the right. That's a K. Kursk. So the area we are talking about is approximately here. That's a bit hard to say, but maybe here. On this map, which is a surface conductivity anomaly. And I found this map because I noticed some repetitive weather patterns on satellite pictures and made some research, and I found that. Yeah, it was interesting. Amazing. So now let's go to the other article, which talks about the region approximately here. So we could assume that it is part of this bigger one. . Summary. The North German conductivity anomaly was detected already in the early years of electromagnetic deep sounding. It refers to the reversal of induction arrows as a graphical representation of the Tipper transfer function, the ratio of vertical to horizontal magnetic field variations. At the northern and southern margins of the North German basin, in spite of the many experiments carried out so far, its origin has remained ambiguous. Explanations encompass a deep crustal or even mantle source, as well as the simple response to deepening of sedimentary sequences in the center of the basin. Here we report on modeling of new long-period magnetotelluric data collected along two profiles in northeastern Germany and South Sweden, or southern, with one transect crossing the Sorgenfrei-Tornquist zone as the main boundary between Precambrian Baltica and Paleozoic belts of Central Europe. With the exception of a few sites probably influenced by 3D salt domes, the data allow a 2D analysis. Resolution is reduced for large depths due to a well-conducting saline aquifer extending across the entire basin. The main result is that the reversal of induction errors can largely be explained by the resistivity contrast between crystalline basement and sedimentary basin fill. Beneath Rügen Island, a southward dipping conductor is interpreted to reflect an alum shale layer in Middle Cambrian lower Ordovician sediments. Beneath the southern bases, a moderately conductive upper mantle is modeled, although not very well resolved, which may reflect the thinning of the lithosphere as implied by seismic tomography. As the main anonymously inductive effect is primarily explained by the basing edges, numerous other anomalies exist inside the basin. We suggest not using the term North German Conductivity Anomaly any longer. So they are talking... they are talking about salt. They have found many other anomalies. And now they are suggesting it's not called a conductivity anomaly any longer. But anyway, there are already so many interesting things just in this summary. Introduction. Now we have to go to some maps. I don't want to bore you with some sketchy reading. But here we have Rügen. Rügen, Stralsund. And that's the area, I think. We will have to check it out. Let's do it like that. That's a screen grab from the article, from the Finnish newspapers. So that's Denmark. I can't draw on that. It's the one here on the left, which is here. I think it's the island which is there. Anyway. Yeah, maybe that's easier to somehow get where we are or understand. So here is Denmark, and we are quite much to the right. And this is probably the one you see here, so we are in the middle of these. This seems to be in this study area, where we have the most interference, where we have this Surface conductivity anomaly. Let's take this off. We have now confirmed that we are talking about the same area. Yeah, we suggest not using the term North German conductivity anomaly any longer. So that's the study area of this conductivity anomaly. There is a river, Oder vielleicht, maybe. There are many rivers going there, rather big ones too. And here is a map. And here you can see the arrows. They are pointing in different directions. Maybe up or down, maybe down, I don't know. And then they're spinning around again. And we have red and very blue areas. And here it's really red. Out in the sea. Approximately where we have this red area. In other words, this seems to be rather shallow. Induction arrows real part for profiles P13, 14 and LT7 out of the period of 1820s. Drawn on an isopatch map of sedimentary thickness to the base of the Permian based on a compilation by Schengel. The trace of the North German conductivity anomaly is located roughly in the center of the basin. Yeah, so that's the anomalous thing they're talking about. There has been somewhere a picture I found very interesting. Yeah, not only this one, there seems to be something. There has been a similar one beneath Rügen. Here we have two other blobs. Whatever they are, who knows? Yeah, maybe these are the blobs which are under Rügen. Not for all sides. Let's read inversions of the same data with weighing parameter arms. The rooms of the model and thus worse than the ones with lower weighting parameter. Not for all sites on the Rügen Islands, however, but the model is more consistent with geological assumptions. Alright. So we are dealing with assumptions. Yeah, you can spend your own time reading that and make your own thoughts about this. And for those who don't know, there has been some very wild weather in the Baltic Sea, and now there's a salt. Well, let's say there's so much salt water flowing now into the Baltic Sea at the moment. I could show you some article I have been reading today, but it hasn't been so much for 10 years or something. Yeah, salt is very interesting, especially when it's in water. It might increase the conductivity. In other words, there's like stuff under the ground which reacts with the weather above. And I think as Earth's magnetic field is weakening, these areas which are prone to activity for whatever reasons, metals or other activities which just need a little kick in order for them to accelerate and doing their thing, heating up stuff and whatever. I've been talking about the auroral display over Iceland some time ago. And if you take the Iceland and aurora display, it seems to be on the mid-Atlantic ridge somewhere. There has just been an earthquake again, 5-pointer or something, which could be underneath the place where this short aurora display happened. And if there would be something going on beneath the Baltic Sea, there could be some GPS disturbances. There has been very low pressure systems in the Baltic Sea. I was supposed to make some videos about that because it was 960 or something. Very low pressure. If this would have been in springtime or something, it would have been... Yeah, this should have been in the news, I think. Like in the tropics, a storm like this, there would have been so much destruction. And we had this at the shortest days on the year, where we are supposed to have the least energy. Yeah, it's very interesting. And now we have this GPS interference over this North German surface conductivity anomaly, which shouldn't be called surface conductivity anomaly anymore, for whatever reasons. Yes. Anyway, I think I'll leave it here. I will put some links below. Check them out. And if you know something I probably should know, which is related to the things I talk about, tell me. If you have a question, ask. We are here to learn. Thanks. Bye.